Concept 3, finding the volume of composite figures. Alright, so a composite figure is just a figure that's made up of two different solids. Okay, so this one we can see is made up of two different rectangular prisms. Alright, and what we're going to be doing is we're going to try and break that into its separate figures or separate solids so that we can calculate them individually and then add them together to find the total volume. Alright, so if I'm looking at this one, I could cut it right here and right there, and that would separate this little upper bit into a really short, kind of small rectangular prism, and then I have a really big one down here, a really long one. Alright, I could also just cut it straight down, and then I'd have an upper right here rectangular prism and a one lying along the ground that's not as long. Okay, either way will work, but often you're going to get more than one type of figure. Okay, one type of solid. So if I look down at this one, okay, now I've got a rectangular prism down here, but I've got a triangular prism up top. All right, and what I'm going to do is I'm going to do my volume for each of them. I'm going to get my formulas. Okay, my volume for a triangular prism. Remember, both of them start off as big base times big height. All right, and in this case, I think I'm going to make the length be the height. Okay, so for my triangular prism, okay, base is 1/2 little base times little height, right? And then times my big height. Okay, for my rectangular prism, it's going to be length times width times big height. Okay, and in this case, my big heights are actually different, right? Because my triangular prism doesn't come all the way out to the end. So let's go ahead and fill this one in. So my big height, right, this length is 6. Okay, I've still got my 1/2. Now my little base and my little height are a little harder to figure out. You can see the little height here, okay, and you want to make sure that you get something that's actually the height of the base, the height of that rectangle or that triangle right there. Okay, so that'll be my height. So that'll be 4. And then my base, this line, and this doesn't tell me how long this is in this figure, so I've got to go looking. I've got to say, okay, I know that this is the same width across, right, this base as this is. So if I come down here, this 6 feet is telling me that this width is 6 feet, and these should be the same. So it's going to be another 6. Okay? All right, and okay, so we're going to go on to our rectangular prism. All right, which generally is a little easier because we don't have to worry about the 1/2 or any of that. So now we're just looking for the 3 dimensions: length, width, and height. Our width, we said, was the same as that triangle's base, so that should be 6. Okay, our length, okay, and that's going to be this one because we're talking about this as our total height. So our length is going to be 4. All right, and then our total height, our big H, for this one was 12. Okay, and now I can get my calculator back out, and we can figure out what these are. So I've got 1/2 times 6, or 0.5 times 6 times 4 times 6. So the volume of that triangular prism should be 72 feet cubed. Alright, and now the volume for my rectangular prism should be 4 times 6 times 12, or 288. 288 feet cubed. And if I add those together, all right, so I get my total, that should be 10, 15, 16, 360 feet cubed. Okay, great. Now, another thing that we've got to look at is a composite figure. Okay, and we can see in this composite figure we're adding, right? We've added on to it. We've put a little roof on half of our barn, or we've just put a triangle on top of or a triangular prism on top of our rectangular prism. But with pipe, okay, pipe is a really common figure. We use it all the time. Okay, whenever you get water, you're using pipes, and those are actually going to be two different cylinders. Right, my outside cylinder, and my inside cylinder, and I'm going to subtract the inside to figure out the volume, like the amount of metal that I have to use to build that pipe. Okay, so now I've got, this is a case where I get to use the same formula, right? The volume is going to equal pi times the radius squared times the height. Oh, and I haven't even given this a height. Let's call this, we'll say we're making a 10 centimeter long pipe. Okay, so this is going to be my formula for the outside, for the total one. Okay, and then my inside one is going to be the exact same, right? Pi r squared times height. So what I'm going to do is I'm going to calculate the total cylinder, okay, the outside, the whole pipe, as if it was a solid bar of steel. Okay, so I've got my radius for the total is 5, right, because I'm trying to find the whole thing. My total is 5, so I'm going to have pi times 5 squared times 10 centimeters, which is going to be my height. All right, 5 squared is 25 times 10 is 250. So this is, oh, that's a weird 2. This is going to be 250 pi centimeters cubed, right? If this was a solid bar, it'd be 250 pi centimeters cubed of steel or plastic or whatever it was made of. Okay, so now what I've got to do is I've got to figure out what the volume of this inner area is, the part that doesn't have any metal in it, right? So same thing, pi, except instead of 5 centimeters, I'm looking at 3 centimeters, right? Because I don't want to include the part that actually has the steel, okay, the solid part of the pipe. So I do 3 squared, again, times 10, because it's the same length. 3 squared is 9. 9 times 10 would be 90, so I'd have 90 pi centimeters cubed. Okay, so my total was 250, and then the inner part was 90, so I'm going to subtract that. 250 minus 90 should be 160 centimeters cubed. Okay, so that's how much actual steel I would use to make that pipe. All right, so when you're doing these problems, be aware that sometimes you'll be adding. Okay, in this case, I'm adding on to it, but sometimes you'll be taking away. You'll be figuring out, okay, I've got my total, right? If this whole thing was solid, but then, you know what, I took some away. So I'm going to have to calculate what that would be and subtract it.